Hello, my name is Daniel Fernandez. I am the webmaster and owner of scienceinhydroponics.com. In this video, we're going to prepare a concentrated hydroponic nutrient solution, and it will be divided into A and B parts. The idea of this video is to show you one of the simplest possible ways to prepare hydroponic nutrients using the minimum number of inputs that a person can get to do this, or around the minimum that you can get to do this cheaply. The inputs we're going to be using are all here. So these are mostly all raw fertilizers. So we are going to be using Epsom salt, magnesium sulfate, heptahydrate. We are going to be using monopotassium phosphate, ammonium sulfate, calcium nitrate, potassium sulfate, and we're going to be using this chelated micronutrient mix from Customhydronutrients. The reason why we're going to be using this chelated micronutrient mix is because generally for small scale preparations you would need only a small amount of these micronutrients, and getting pounds of these micronutrients can be expensive, especially things like sodium molybdate. It's way more practical for people who want to do small scale preparations to get this sort of chelated micronutrient mix. In this case, my nutrients are for Customhydronutrients. They are not sponsoring this video or anything, but they have all the nutrients that I wanted in relatively small quantities for this video, but you can get them elsewhere. Now for the formulation, we are going to be preparing a solution that has a concentration factor of basically 250, which means that we need we're going to use 4 milliliters of the concentrated solution A and 4 milliliters of the concentration solution B for every liter of final solution we want to prepare. And these values that you see here are to prepare 250 milliliters, which I'm gonna prepare in this volumetric flask. So the reason why we are going to do it in this volumetric flask is because this is the way that we can prepare this accurately at a small volume. And you'll see that it's very important to do this because knowing this final volume is extremely important, otherwise the entire preparation will be inaccurate. The final ppms of the solution, you have them here. This is a generic formulation, more geared towards a little bit more geared towards flowering plants, but it will work well for a wide variety of different plant species. You can find this entire image within the description and in a blog post I made where I also describe this entire process in case you want to go through that. Today we're going to be preparing this small amount, and it's not as easy to prepare a bigger amount of this because preparing larger amounts accurately is harder. So we're gonna do that in future videos so that you can see how can I prepare a gallon of this, because it's not just get a 1 gallon bottle and prepare it there, because that would be very inaccurate. So we need to have a standardized way to prepare a higher volume, which is something that we're gonna discuss in a future video. So now the A solution is going to be comprised of only calcium nitrate, and we're going to do that second. First, we're going to do the B solution, which will be comprised of all the rest of the chemicals we're going to use. To prepare this accurately, we are going to use this small scale, which is a pretty cheap scale that has enough accuracy to prepare this. And this scale measures up to 0.01 grams, and it has a maximum weight of 500 grams. So it can weigh pretty heavy things, and it can weigh all these different weights that you see here that are the ones that we're gonna need to prepare these 250 milliliters of nutrient solution. First of all, you'll notice that I have 2 beakers here. One beaker I'm gonna use to prepare the solution, to mix things before transferring to the volumetric flask, and the other one I'm gonna use to weigh things. First of all, I am gonna purge this with distilled water, just to make sure there is nothing here. which if you've seen my other videos, pretty standard. always purge this, the glassware you're gonna be using, otherwise it might be contaminated. You'll want to have some kitchen towels to perform this process and to dry. So I'm going to dry this so that I can now weigh. So I'm gonna put this here. Now, when you're weighing stuff, you always want to start with the smallest things, because if you weigh the small things wrong, then you'll lose the smallest amount of material. If you do it the other way around, then you might weigh a very heavy thing first, and then when you weigh a small thing wrong, then you lose everything. So start with the smallest things. In this case, we're gonna start with 2.225 grams of the chelated micronutrient mix. So I'm gonna tear this, and these chelated hydroponic micronutrients are pretty hazardous. These are chelated heavy metals, so be careful when you handle this. Make sure you don't rattle it a lot. You don't want any dust, so make sure you're very careful when you weigh this and when you handle it. You don't want to generate any dust, and you want to wear some sort of face mask or protection if you are going to work with any significant quantities of this. Of course, always wear gloves, because gloves are very important to protect your hands. These heavy metals can also be absorbed pretty easily through the skin because they're chelated micronutrients. So make sure you do that. So I'm being pretty careful here to get to the actual values I want. So I'm gonna weigh it with this precision, so I'm gonna leave it there. So this is 2.20 grams. And you might want to, you will need to write everything down so that you know exactly what you weighed in, so that you can then calculate the actual composition you have from what you actually weighed, and you know exactly what you're putting in. So now I am going to remove this from the scale, and I am just going to wipe it clean, because you always want to clean things before. If you can get a little brush to clean this, it will often be better. Now I'm going to transfer this. So I am going to use this distilled water to transfer this material to this beaker. This way I can ensure I get everything out, and it will start dissolving everything. So when you're doing this transferring process, make sure you get everything out of it. But we also need to keep an eye on the volume on the final volume of solution that we have here, because we don't want to reach a very high volume, because remember that we have a limit of 250 milliliters. So I'm just ensuring I get everything out, and you can see now that the water is completely clear. So we've transferred everything. We can now put this back here. Now I'm gonna dry this again. Now I'm gonna tear this again, and I'm gonna do the second smallest, which will be the ammonium sulfate, sorry, which is 2.3 grams of the magnesium sulfate. .331. So I measured 2.35. 2.35 is the weight I measured. So now I'm gonna repeat the process I did before. I'm just gonna transfer this, so just dump the solid, and then I'm just going to wash it to get any remaining. And I'm gonna place this back here. And again, let's ensure this is perfectly dry. Put this back here. Try this again. Now we're gonna do the following one, which is the potassium monobasic phosphate. This one, which we're gonna be doing 10.985 grams. .98 grams. So that was pretty precise as far as this scale allows. Then I'm gonna repeat this process. Take this here, I'm gonna add the solid. And now I'm gonna transfer. Make sure this is all transferred. Let's wipe this clean. Now the one that follows is the potassium sulfate, which we're gonna be weighing 25.68 grams. So this potassium sulfate is not great. Like I bought a potassium sulfate that happened to be organic, which means that it's mined. So I don't know if you can see there, but there are a lot of like dark specks inside of it. So it is not very pure, so we'll likely have a significant amount of impurities in our concentrated solution due to this stuff. So in the blog post that I made, I actually link to a better potassium sulfate than this. It's also in Customhydronutrients, but you can get it from wherever you want. So this was my mistake, so I'm gonna prepare it with this one, but if you can get the better one, which is more crystalline, then that will be better. So it's 25.69 grams of this. Getting there. Okay, so I'm gonna leave it there at 25.64 grams of the potassium sulfate. Always remember to clean your spoons or spatulas that you're using for this. Now I am going to put this here and just dump this in. And as always, we are going to ensure that everything is transferred using distilled water. Just make sure you wash that very thoroughly. I'm gonna wipe this first to ensure it's dry. And I'm gonna just wipe this clean. Every time I wipe the scale, I just use another towel to ensure that I'm not contaminating the glassware between weighing different things. Maybe you can see my cat's tail there. Now I'm gonna do the magnesium sulfate, which is 31.69 grams, which is our heaviest contributor. And that you just saw happening there was static electricity, which it happens when you have low humidity. So it's usually better to weigh under a little bit higher humidity than I have right now here, because I'm in a pretty dry climate. So this is 31.67 grams, although it's probably a little bit lower due to the stuff that is here, so I'm just gonna wipe this and then put it back here. So 31.63, and now we're gonna repeat the previous process and add these in. And one reason why having an accurate total volume is very important. All these calculations that you see to my left that were made using the Hydroponics software were made for a given volume of final concentrated nutrient solution. And you can see how much volume the salts are taking. Like, the salts take a lot of volume, take up a lot of volume, and they are not dissolved yet. So now I am going to dissolve them. So in this small scale preparation, I added them all at the same time, and now I'm gonna go through the dissolution process with everything already mixed in. Usually when you do this, you will want to, if you're doing especially larger scales, or if you want to do this easier, you might want to dissolve them one by one. But in small scales, it's usually easier to add them and then have everything dissolved. Now you see here that I have these lines you cannot trust very much, so these volumes that you have on these beakers are pretty inaccurate. These volumes are not very accurate, but they are very rough estimations. So this is a 250 milliliter beaker, so we know we can go up to like sort of like the 200 level, knowing that we'll have enough volume left to complete to that. And we want to add as much water as we can, or at least a lot more water here, so that we can dissolve all of this, because these salts, especially this very impure potassium sulfate, is not very easy to dissolve. So now I am going to heat this up, because dissolving this under these conditions is not easy at all. So I'll need to heat this up a little bit, and then I'll be back whenever this is already heated. Okay, so now that we have heated the solution, everything is now pretty much dissolved, although we still have a little bit of cloudiness because of the impurities in the potassium sulfate. So this is not going to dissolve any further because of those impurities, but everything that needed to be dissolved is now dissolved. So now I'm going to transfer this into the volumetric flask. So an important point to make here is that these must be at ambient temperature when you do this. If you heat this, then you must let it cool before you transfer, because using hot material on a volumetric flask will make it lose its calibration. So the first thing that I'll do before I transfer anything will be to purge the volumetric flask, as we always do. Remember, always purge your materials with distilled water. Now, I don't think I've mentioned this in the video, but all of this is done with distilled water. You cannot do this with tap water. And with RO water, it depends on the quality of your RO system, but when you prepare concentrated solutions, just go with distilled water. Like the additional cost if you're doing small amounts is not that big, and you'll get way better results. So now I am going to make sure if you're mixing with something, make sure you use distilled water to get everything out so that you don't lose accuracy, so that we ensure that all of our stuff is there. Now I am going to take this and I'm just gonna transfer these into the volumetric flask very carefully to ensure that I don't spill anything, which can happen. This is why using beakers is something I would recommend, because beakers are designed to facilitate these transfers. So doing this with any other sort of material is pretty hard, while a beaker makes it incredibly easy. Okay, so now we've transferred almost all of it, but you can see this beautiful white crap here. This beautiful black crap all over the place. Those are the impurities of the potassium sulfate, but we're actually gonna need to transfer them, because we need to ensure that we have transferred everything we weighed. So I'm just gonna transfer as much as I wash these and try to transfer them. I don't care too much if I get some solid in there. Just I'm making sure I wash this so that I get all the actual stuff that we're interested in. So this means that the potassium sulfate portion of the solution won't be very accurate because of this. Now I'm not gonna transfer all the solid because the solid did not dissolve, and I've already washed it, so I'm gonna wash it one last time to ensure I get anything that can dissolve there. Okay, so I'm not gonna get this black crap, not gonna get it. Those are the impurities of that potassium sulfate, which are basically because it's mined, not purified. And we have here our nice solution. And now I am going to just add a little bit, well, I might as well just wash it more since I need to add a little bit more volume. So I am just going to add a little bit more volume here. And I'm gonna stop right there because that final part I wanna do it very accurately. So I'm gonna use a needle and I'm gonna get some distilled water. So in order to do that, I'm going to first purge, although this has already been washed with distilled water. So I'm just going to do it once. And now I'm going to just take some distilled water using this. And I'm going to measure this if I can. Okay. I hate when this happens. Just a little bit short. So I am just going to add a little bit more till I reach, till the meniscus is right above the line. And that is done. So this is now prepared, and I can now just mix to homogenize the concentrated solution. And there you have it. We have our B concentrated solution for our formulation. So now I'm going to transfer the solution into a container to store it. And to do this, I am going to use just a random glass container I had available. So you can use any clean container you already have, clean glass container. And I'm just going to pour my solution here. And I will just store it within this container. And this is the final solution. And now this is full of the remaining part of the solution, so I'm just gonna wash this very thoroughly. Remember that the A and B solutions are incompatible, so we need to make sure that this is pretty well washed before we do the preparation of the other solution. So I'm just gonna purge it again with distilled water, just get everything out. Do not use any soap. So people, when you say clean, people imagine soap, but soap is actually terrible in this case because the next solution we're going to prepare is a calcium nitrate solution, and soap precipitates with calcium nitrate because the salts that soap is made up of, the calcium salts are insoluble, so they will precipitate. So we don't want to use any soap. We just want to make sure that we get everything with distilled water, and that will be more than enough to ensure that our formulation is not an epic fail. So I'm just gonna leave this here. You don't need to dry this, just if it only has distilled water, then it will not affect the accuracy of your processes. Now this is the beaker that has all that potassium sulfate crap, so I'm just gonna throw that away, and I'm now going to clean it with distilled water. and I'm just gonna dry it with a paper towel to ensure that it's clean and dry for our next solution. So since we're only going to be weighing one thing for the solution, I'm just gonna use this beaker and I'm just gonna weigh everything here and then add water if it's not that heavy. Yeah, so we can use just this beaker for this. Bear in mind that you want to know what the maximum weight of your scale is, and you want to take that into consideration. You cannot, if your scale does not allow you to have this within your range, then you'll need to just weigh and transfer. But in this case, I'm just gonna weigh this here. So calcium nitrate, we have 68.70 grams. So I'm just gonna tear this, and 68. Went a little bit over. So 66. 68.84. So I am just going to use that. 68.84. So that will mean that our calcium will be slightly higher, but as long as we know the weight and we know what we're preparing, it's fine. And now I am going to take this off and add some distilled water. And I'm just going to purge this spoon with distilled water. And now I'm going to use it to mix this. So calcium nitrate will cool your solution because when it dissolves, it takes energy away from the solution. So you will actually see your solution's temperature drop. And this might make it hard to dissolve if your ambient temperature is already pretty low. So in this case, it will just be a couple of minutes. Calcium nitrate is generally not that hard to dissolve, especially if you are dissolving it on its own, if it's not accompanied by anything else. Since we're now doing a nutrient solution that is very simple, we are just doing an A solution that is the simplest possible A solution you can make, which is usually just a calcium nitrate solution. But sometimes you will want A solutions that are more complicated. And A solutions will generally contain magnesium nitrates, potassium nitrates. Sometimes the iron in the micronutrients is placed within the A solution. These are all things that you can do depending on what your objectives are and what your final makeup of nutrient solution is, and also how you're going to schedule the nutrient solution. In this case, we're doing a nutrient solution that you basically will use in the same way through the entire crop cycle, although some scheduling can actually be done, and we can explore that with a solution this simple, which is something we can explore within the next videos, or a video in the future. So this is almost all dissolved. It will be cloudy because it first forms a very small solid aggregates in solution before it actually goes into solution. So it will be cloudy for a while, but you can see that there are almost no preels left. Calcium nitrate is usually sold in this sort of preel form, which is typical of substances that are very hygroscopic, because otherwise they would cake. If they did not preel it, it would just cake into a block and it would turn into something like cement. So they are preeled so that they can be packed and shipped, and that will not happen. So now you can see that the cloudiness is starting to go away. So that's pretty much done there, and I'm going to always remember, if you're mixing with something, make sure you wash it so that you don't take anything away. So we want this to remain accurate. So the spoon is now off camera, and now we are going to perform the same process that we did last time, and you'll see if I purged this correctly. So I'm not gonna take any chances because I don't wanna tarnish my reputation. So I'm just going to purge this one last time to ensure that we don't get any precipitation. You can see that there's some foam there at the top of this. This is because calcium nitrate is usually some anti-caking agents are used, and those turn to be surfactants. So you'll see that these solutions can foam a little bit, calcium nitrate solutions. So I'm now transferring. It's pretty cold, you'll feel it when you do this, that the solution is very cold. So I've successfully transferred this, but remember that you always want to wash with distilled water. So that's why we didn't take it to any higher volume, because we want to have some available volume in the volumetric flask to perform this sort of process, because we want to get everything. So we need to have enough extra volume to perform these washing steps, otherwise we'll just leave some nitrate on the inside the beaker, which is not something we want, because we want all of it to go to the volumetric flask. And we don't weigh things in the volumetric flask because we are not savages. So now I can do the same thing I did last time. I can just add some distilled water to just add till we're close to the final stage. And you'll see that the solutions that are foamy have this very annoying property that when you have a foam like this, being able to see the meniscus can be a little bit complicated. So usually what I'll do is that I'll try to rotate it a little bit like this to see if I can reduce this a little bit. So just do this sort of shaky rotation to see if you can bring it down. If not, like, you can probably see the bottom of the meniscus still. So I'm going to just take some water here, and I'm going to get it to the guess it's just bad luck today. Get it. Remember that the meniscus must be right above the line. Okay. We'll do the final step of the process, which is to cap this. This was also used for the previous solution, so you might as well purge it. Put it on there, and that's it. We have now our A solution, which I am going to do the same thing that I did last time and store my A solution inside a glass container where I can draw it from whenever I want to prepare my final hydroponic solutions. So in order to prepare a final hydroponic solution from these concentrated solutions we prepared today, you would use 4 milliliters of this solution plus 4 milliliters of our B solution, and with those you will be able to prepare 1 liter. So with the amount we prepared today, which is 250 milliliters, you'll be able to prepare 250 times that. which is around 60 something liters, yeah, which is close to 70 liters of final hydroponic solution. So it's a lot of solution because this has a 250 times concentration factor. So whatever volume you prepare from this, you'll be able to prepare 250 times that volume in final nutrient solution. I hope you found this interesting. This is how you can prepare a hydroponic nutrient solution from raw fertilizer salts, and you can see it's not incredibly hard, but it can be done pretty easily with chemicals that are pretty easy to get, and you can do it yourself. If you need a generic hydroponic nutrient solution, that will allow you to grow plants, either leafy greens or flowering plants. This will do, although of course for optimal results, and if you want to get much deeper into it, there are, of course, it's an entire universe of how to do this. So thank you very much for watching this video. Remember to like and subscribe, and check out my website, scienceinhydroponics.com. Leave your comments here. I love comments. Please leave comments, otherwise it might be depressing. So thanks again for watching. I'll see you on the next video. Bye bye.